Good afternoon, everyone. Welcome back to this next session on energy-related issues. So right now this session is on larger scale integration of renewable energies in energy efficiency in cities. So it's also under the frame of the European Energy Research Alliance organized. And if you have had the opportunity to attend the plenary session on energy, the introduction has already been put on the table. I mean, there are some key elements around when talking about smart cities. We can say that almost everything is there. We have to notice, highlight the keywords. That could be integration. That also could be, when talking about energy, energy efficiency. And when talking about smart cities, could be the interdisciplinarity, which means involve everyone, every citizen, every discipline. So we're going to have a session, four speaker session. First one is going to be Annemie Wyckmans. Annemie is professor in sustainable architecture at the Norwegian University of Science and Technology. She is developing and promoting strategic research in architecture and urban planning, and in particular related to smart cities. Is not only at national level, at Norwegian level, but also at European level and international level, meaning collaborations with China, for instance. So the floor is yours, Annemie.
Thank you, Pablo. Let's see. There it is. Yes, so my name is Annemie Wyckmans. I'm an architect. I work at a faculty of architecture, which also deals with facilities management and urban planning and design. We work with buildings, neighborhoods, and cities. And I am coordinating a sub-program on energy efficient interactive buildings within this EERA joint program, which is hosting the session. Now, the starting point for my talk will be that, so we want to have a large-scale integration of renewables and of energy efficiency and of smart ICT technologies. What are we going to integrate it in? What are we going to integrate it with? So that's going to be the starting point of my presentation. And one thing is that whenever I tell my colleagues that, oh, I'm going to attend this Smart Cities event, or we have these and these projects within Smart Cities, they say, oh, that's nothing for me. You know, I'm an architect, I'm an urban planner, I'm an urban designer, I'm an engineer, I'm a social scientist. I just deal with the built environment and people. I don't deal with smart. That's quite unfortunate, because in order to really create smart and sustainable cities, we need all of these disciplines working together and being aware that they are a very important part of making this actually happen. So one starting point is that smart, sustainable cities is not about how much ICT we can get into a city or how much renewables we can get into a city, but that we stop looking at cities like polluters, but rather we think of smart, sustainable cities as the way in which they are designed and managed. The easiest thing you can do as a consumer or as a citizen is actually something that's energy efficient, climate resilient, health promoting, inclusive, attractive, etc. So you don't have to do something extra or something more expensive or more time consuming in order to do something energy efficient, because the city has already managed that for you. It's easier said than done, but it's quite an interesting challenge. And in order to actually achieve that, we've listed some examples or some of the different disciplines that would need to be involved, some of the topics that need to be involved in order to achieve that. If you look at the city as an urban ecosystem, as an ecosystem in which energy is included, innovation is included, ICT is included, then you need all of these different things. You need the built environment with its materials and details and urban mining, reuse of materials, etc. You need the buildings and infrastructure and transport, mobility. You need the blue-green infrastructures. But also you can't do without people and institutions. A smart city is a smart city smart if it doesn't promote the health of its citizens, for example, or the well-being. If it doesn't deal with consumption and behavior and user participation, how do we? It's not just about ICT technologies, but also how they can improve planning and design and how they can deal with ownership structures. And then in terms of value creation, so there's so many different disciplines and different types of stakeholders that have valuable bits of information, but they usually don't talk to each other, or they don't even know of each other, that they exist. How do we connect them to each other? How do we find out what kind of services people need? How do we create attractive cities? How do we create not just economic value, but also cultural value? And how do we make sure that all citizens can benefit from this, not just the ones who can actually afford to be energy efficient? So basically, I've selected 5 main topics which are based on projects that we're dealing with. The sad part is that, the good part is that all of these topics are actually dealt with. There's projects on them, there's knowledge, there's good methodologies, there's companies interested and cities that are interested in these. The problem is that they're bits and pieces, they're fragments of people that are not necessarily talking together, institutions that don't know of each other, that they're actually working with this. So one encouragement from this presentation and after this presentation is how do we actually complete the puzzle? So a first bit is integrated assessment, which everyone's familiar with, I guess. Putting lots of solar cells, solar panels on top of a building doesn't necessarily make it energy efficient or doesn't necessarily make it zero emission. So we have a national center on zero emission buildings where we deal with materials, facades, energy systems, people, pilot projects. And the thing is that if you want to do a pilot project where you reach towards zero emissions, it's not the solar cells that are going to make the difference. You need the solar cells in order to generate enough energy, but the solar cells themselves have so much embodied energy that you need to compensate them with something else. So how do you design the building itself with all of the steps you have here? Every single step of these has to be included and integrated. Otherwise, you're never going to reach a zero emission standard. We know, we've tried it in practice, we've tried to calculate it, we've tested it with people. You don't get there unless you actually include all of these things. If you manage one building, there's always the danger that there will be another building next to you that's being erected and it completely shades your solar cells and thereby destroys your zero emission standard. This is actually an example from Trondheim. Lots of calculations, lots of planning on beforehand for the building in the back. Half a year later, the building in the front gets permission to add 1 story to the existing building, overshading the solar cells. How do you deal with this? So could no one have foreseen this, for example? You know, in urban planning, in the routines we have, you can't really spend so much time on calculating and planning if then something like this happens. So we really need to deal with this on all kinds of levels. if you then, it's not just about one and one building. If you then go towards smart energy communities, we've looked at what kind of indicators exist for energy efficiency and renewables, including also stationary energy mobility. There's a whole bunch of them at different levels. You need to aggregate from one level to reach the other one, but there's no clear relation between these different levels. There's so many indicators that you can't possibly deal with all of them. Which are actually the core ones? Which do we need to deal with? And which ones are, nice but additional? We haven't solved this yet. We're trying. And then if you've dealt with the stationary energy and community level, you have this whole other level of economy, land use, climate impacts, demography. Which again create, you need a lot of other disciplines that are involved. So for each level you add so much complexity and so many people that need to be involved that there's a lot of work to be done. The smart ICT systems and the smart renewable energy solutions are not going to help unless we can get them integrated in this, which, well, most of my colleagues would call proper urban planning or proper urban design or proper, architecture, building design. So we really need to work across these different disciplines. A second issue is, if you look at this, you could think, well, it's about a lot of numbers and systems and smart grids, etc. Actually, you need to integrate it in some kind of mostly existing urban environment in Europe. You need at least to build some kind of built environment. You need buildings, you need infrastructure, you need nature in which this is going to be integrated. And we have no way of knowing what the value of these different forms and designs are.
Just 3 minutes more.
Okay.
There's no that. 3 minutes.
Okay, great. For example, this is one of those pilot buildings which we work with, so which we have created in order to reach zero emission building standard. This is a renovated building. It has created a lot of enthusiasm among developers and industries that deal with materials, facades, etc., energy companies. Now, the thing that's interesting to them is not that, this is near zero emission, including the solar cells and the embodied energy of the materials, etc. The interesting thing is that the interior looks like this. When you show this to clients, to people to whom you're going to rent the office space, or you show this to any other kind of user or developer, they think, yes, we can sell this. It looks nice, feels nice. When people come in there oohing and eyeing, not because it's zero emission, but because basically, yes, this is what people want. And you see that there's been a lot of time spent on every detail and material and the space and the colors and the light. So everything is so well thought through just because we needed to reach that zero emission standard that actually the building is quite well designed, and that's what people react to. So this value of a form is something we can't yet quantify, but we see the reaction from the developers, from the industry. They're queuing up in order to be able to work with the researchers in order to create new buildings like this or renovate their own building stock. Another example is this. This is a home, again, towards zero emission, and the interior looks like this. This is something a real estate manager can sell. They won't sell it because it's energy efficient or it's zero emissions. They will sell it because this is the way Norwegian people want to live. So first you need to figure out what do we need to do to reach energy efficiency, zero emission, and then how do you sell it to people? How do you convince industry to be part of this? It's not just buildings, it's also nature-based solutions. I think I'll just skip this. Basically, it's that Also here we don't really know the value. We know that people react to, if you have this, putting a green wall on a square, it will make more people stand still in front of that green wall. People will be there longer, more people will be there, even if the wall doesn't have any apparent function. What do we do with that? Does it actually, how does it make people use a space? How can we use this kind of knowledge to also make smart cities? And then we come to the next point, which is exactly how do people actually experience and use their environment? So if we know more about their behavior and their wishes, not just we can use smartphones to track people, but if we also know more how they react to the design of their built environment and we combine it with the information we get from a smartphone, then we can actually make environments that people can be energy efficient more easily. For example, so we know that good design actually it enhances accessibility and usability and functionality. Bad design can easily create malfunctions, and it really creates a hindrance in people's daily lives. It doesn't help then to have a smartphone, but if you connect the smartphone to messages about flooding, about energy peaks, about transport queues, traffic queues, for example, then you can actually get a lot of work done. Yes. So we need to find out more how people use their environment and why, and how we can work with that together with the ICT in order to really design smart cities. We need lots of different kinds of people. Most of these people on the list don't know that they could contribute to smart cities. How do we reach them? How do we work with them? Not just the disciplines, but also the end users. How do we get them involved? Not just in using the smart city, but also in being part of designing and planning it. There's a lot of projects going on in order to try to get whole lots of different disciplines involved. You can look at these afterwards on all kinds of different levels. And the last one is then that, of course, it's not just a theory, but testing it out in real life, seeing how people actually use these environments and how we can improve them based on that experience. So this is one neighborhood we're developing in Trondheim. It's going to be smart and health promoting and energy efficient and climate resilient, hopefully. We work together with the site owner in order to achieve this. It's not about one-on-one project, but we've been doing that basically for 100 years. First with little test buildings at campus. We're still doing test buildings on campus where people actually can live for several weeks, so we can see how they respond to the different systems. And it's not just about the little things on campus, so it's the whole urban lab, being part of creating neighborhoods, being part of helping cities and helping industry to better develop land use and transportation, finding out how ICT can actually create better urban planning, better urban design, how it can help social inclusion, how it can help governance processes. So basically, that is what we do, and we hope that other people are joining this effort. If you're working on such projects, please let us know. Maybe we can cooperate. Thank you.
Okay, thank you, Annemie. Thank you for giving us some insights on the opportunity of cities in this energy transition and emphasizing the interdisciplinarity of the smart cities context. So, next speaker is Bernd Vogl, is head of Vienna's Department for Energy Planning since 2011. Formerly in charge of innovative energy system in the Austrian Ministry of Environmental Protection, and now the main focus of his work is the development of renewable and energy efficient solutions for Vienna. So Bernd is going to show us the real case, real situation of Vienna, and also the open challenge there.
So thank you, Pablo, and thank you for inviting me to this exciting conference. I had a lot of interesting discussions up to now, and I think there will follow certain discussions. At the first part of my speech, I will make a trip with you directly into the energy system of a large city like Vienna. And in the second half, I will discuss solutions if we want to change these energy systems to renewable energies. So, Vienna has 1.8 million inhabitants. The area is 415 square kilometers, and we have around 50% of green areas. As a lot of cities all over the world, we are growing very fast. In the last 10 years, the growth was 9.4%, and the projection is that we will have 2 million people in Vienna in 2030. If we look at the energy sector and in the CO2 sector, we have a quite energy efficient system. We have around 3,000 watts per head. In Austria, we have 6,000 watts per head energy demand, and the same is true in Switzerland. In our energy system, we have around 11% renewables, and 11% comes from waste heat. Here you can see the incineration plant, which was designed by Friedensreich Hundertwasser, a famous Austrian artist. Why is our energy system so efficient? We have a real high proportion of public transport. We have a real smart public transport system, which is around 39% of the model split, and this helps a lot when you want to save energy, because the transport sector uses a lot of energy in big cities. We have around 27% cars in the model split of the Vienna energy system. Next point is that we work on spaces for smart living, on biking, space for cycling, walking, and so on. This is an ongoing process, and it's really important for cities to develop spaces for this kind of activities. If we have a look at the heating system, which is very important in cities because a lot of energy is used in the heating sector, you can see that our heating system was developed in the last 20 years towards district heating. So we have now around 40% district heating in the heating system, which is mainly driven by combined heat and power plants. So 75% of the heat is from combined heat and power plants, which have now economical problems because electricity is getting cheaper and cheaper because of the renewable electricity, and the electricity from the combined heat and power plants is hard to sell. So we have a lot of economic problems with the system at the time, and 25% is from the incineration plants. That's the district heating. The rest is a lot of natural gas, around 50%. And we have reduced our oil heatings and heatings with direct current. And we have nearly no coal in our heating systems up to now. So it's quite efficient, but it's mainly based on fossil fuels, as you can see. Next point is that in Austria we have very comprehensive building codes, and the same is true in Austria. We have in Vienna. We have connected our subsidizing systems to building codes. So the buildings in Austria are highly efficient at the time. So this is a very good position. We have spent a lot of money into the renovation of buildings since 2000. So we could reduce the CO2 emissions in this sector by about 20%. And this is an ongoing process, which is very important for reducing CO2 emissions. And now have a look at the energy flow of Vienna. You can see that we have an efficient energy system, but it's mainly based on fossil fuels. You can see we have, I hope this works, we have fossil fuels here in the transport sector, of course, and we have natural gas for heating and for combined heat and electricity production, where we have a lot of economical problems now. And the question is how we can challenge these problems. So what we are doing now in Vienna, this was the situation we are having now. A little step, but I think it's a very important step. We want to change thinking about energy. We make an energy report every year. And now we started to talk about not only kilowatt hours, which is very abstract. We are talking now about PV area. So we take the amount of energy used and say how much PV area is needed to produce the energy. And if you are doing this for Vienna, you would need 2/3 of the area of Vienna to produce all the energy used in Vienna. This is a square with 17 kilometers. In the first time it sounds horrible, but I think that's not so a large area. We will publish this report this year in English too, so if you are interested in this report, please give me a card and we will send it to you. We have decided a smart city strategy in the middle of the year, which has a lot of comprehensive targets in the energy field, but it's based on three pillars. We have the quality of life, we have the resources, and we have the innovation. For Vienna, the quality of life is very important and a strong pillar of our smart city strategy. But of course, resources is a topic in a smart city strategies because we have to use energy, mobility, and infrastructure in a very efficient way to get in touch with our smart city targets. So if we look at the targets in the energy field, we want to reduce the greenhouse gas emissions by 80%, which is in line with the EU targets, which means that we would have CO2 emissions per capita of less than 1 ton. And that's really a good mark when we can reach this. We want to reduce our energy consumption from 3,000 to 2,000 watts, around 30 to 40%. And we want to bring more renewables within the energy system. So we want to develop 50% renewables for the Vienna energy system. And very important, the transport sector. We want to reduce the traffic by cars to 15% in 2030, which is really an ambitious target. And 2050, less than 50% cars should use 100% alternative drives. That's really ambitious. And if we look at the transport sector, and you know from the energy flow, you have the fuels for the transport sector, which are all fossil fuels. So if we reduce from 37% to 15%, we will have more public transport, we will have more bikes, and we will save half of the fuels from this sector, for this sector. And the second half, we will be driven by electricity in the future, I think. So in Austria, we have a very good developed electricity system based on renewable energy. So we have around 80% renewable electricity in Austria. So if we have electricity for our cars, we use mainly renewable electricity, and this will be true in 2050 in most of the countries, I think. A few words on the transport sector because it's a very important target. I think electric cars driven by renewables, this is a realistic target for 2050. Why is this the case? Cars are changing every 10 years. The supply of electric cars is developing rapidly. And the electricity companies will find new business models, and up to now they are, in my point of view, they are the losers of the Energiewende. So maybe this is a chance for the electricity companies in the future. Meanwhile, solar and wind energy are cheap. There is a new study from the Bavarian Ministry of Economic Affairs, not Environment, telling us that PV is the cheapest form of electricity for Bavaria for the future. That's very interesting. So, if we are changing our traffic to electric traffic and reducing the cars to a half, we have more than 50% CO2 saved in the Vienna energy system. That's an interesting figure, I think. The big challenge, in my point of view, is the heating sector, because we cannot change heating systems at that speed. So let's have a look at the heating system, where we need renewables and waste heat and efficiency to develop this sector further. First point is bringing down heat demand, of course. So we need further support for refurbishment. Okay, have to speed up. There you see the refurbishment of the Vienna University of Technology, which reduces the energy demand by 90%, not 19, 90%. A really nice project. So if you visit Vienna, you have to look at this project. Second point is we have to develop new sources for our district heating systems, because we do have a problem with the combined heat and power plants, and we need more renewables in this system. We are working out the Renewable Action Plan, which is coming soon, and we are discussing a lot of new sources for our district heating system. First idea is to use geothermal energy for the district heating system. We are thinking of using the Danube River. We need new sources of waste heat, and also solar heat is maybe a topic. Third point is, if you remember at the left side, we have the gas boilers in our energy flow. And that's really complicated because in Vienna we have energy boilers for each flat. So if you want to change this, this is quite complicated. I think we will manage to change some kind of these boilers, yeah? But we couldn't change every boiler till 2050. So the second question is, will we have gas from renewables in 2050? And I think if we develop the renewable electricity sector, we will have some amounts of gas produced by electricity from renewables. And this could be used in the gas boilers of the cities. New buildings, of course, new buildings must be very efficient and using renewables and waste heat on site for heating and cooling. We have now, since the middle of the year, an obligation for non-residential buildings to use renewables on site. A really interesting measure. We will see what it brings. Okay, I can skip this. And we have decided an urban development plan in the middle of the year, where at the first time smart energy planning is part of the urban development plan. And that's really important, because you have to think energy together with urban development from the first moment on. Yeah, then you can get good solutions for the future. So what we are starting to do now is energy concepts for large new city developments, energy criteria for larger projects, and we are trying to modeling the energy demand of the city, and to look where do we have renewable energy sources and waste heat sources which could be used from the building sector. So that's really an important task, and we have a lot of work to do in this field with my little department. Yeah, that's the end. We need a lot of innovations. Bernd Picard wants to fly with a solar plane around the world, and that's the kind of innovation we need if we want to change to renewable energies. Thank you.
Okay, thank you, Bernd, for this overview on Vienna's current situation and declaration of intentions. So there's room for renewables, and the intention is to shift from fossil to renewables. So it's a good practice and example for the city. So next speaker, Kieran, will bring us a solution from some of your problems, I hope. So Kieran is Research and Development Manager of the Nimbus Center in Cork, Ireland, and his company, Nimbus, delivers solutions for energy-efficient buildings, water transportation, ambient system, and smart cities. And he received his PhD in 1997, microelectronics. And he researched novel hardware for the Internet of Things. So, Kieran, the floor is yours.
Thank you very much. I'm going to talk about how smart cities meets the Internet of Things. We have a number of projects ongoing within our institute, which is based in Ireland in the south in Cork. And we do quite a lot of work, collaborative work, nationally and internationally. And what we're trying to do is take embedded systems, network them together, and deliver solutions in the energy space and in the smart city space that work. I'm going to move quickly by looking first at smart cities and how that connects to networks and to this concept of the Internet of Things, the challenges there, and also the challenges that emerge when we start to look at implementing system solutions for smart cities challenges. I'm going to look at a particular case study, which is a European project that we're working on called Cooperate, and then I'm going to draw some conclusions and make some connections to the other speakers. One of the things that's key about the smart cities is this initiative has started people focus on measurement in a way that hasn't happened and isn't something that was part of the past. We're all well aware, for example, that many people are moving into smart cities now. By 2050, this will be a world dominated by urban centres and driven by what is good or bad about those centres. Building consumption, which drives a lot of energy consumption and CO2 emissions, are a central aspect of that and must be addressed. And in particular, we must address this based on the existence of legacy systems and the legacy stock. Many of the buildings that will inhabit the cities of 2050 are already built. Transport and congestion is responsible for a significant amount of trouble and challenge in the context of smart cities, but also a lot of solutions are emerging quite quickly, and a lot of the causes of economic loss around transport can be quantified city by city, street by street perhaps, and solutions can be found and developed. And transferring those solutions from one city to another is perhaps one of the larger challenges that we face. Air pollution is another example. We can measure the cause of our health problems and relate and link them back to premature death. We can link air quality to asthma, and we can warn in real time so that people can respond and can operate from the point of view of their health management plans and work with primary care centres to resolve personal issues, while at the same time at a city level a larger amount of efficiencies being put in place to reduce air pollution. And in a way, the Internet of Things is kind of characterised by this personal interaction and this city level or this global level efficiency. If you network things together, if you create an Internet of Things, you increase your ability to measure, you increase your ability to manage. And with the help of industry, you can transfer efficiencies from companies to cities. It's not easy, but it's doable. And it's one of the reasons why the Internet of Things is more than just a fad or a trend. There was a presentation there a few weeks ago by one of the VPs in Intel who was talking about the Internet of Things. And he had two separate messages, really. The first one was perhaps the best example of an Internet of Things is the fabs that are used to create the silicon that drives a lot of our embedded systems. They're very highly controlled environments. From room to room, building to building, everything is connected, everything is managed with precision. And the concept of taking that know-how and translating it into the real world and translating it to cities is a very doable, very manageable exercise. It is something that we can do. The other aspect of his presentation looked at the Internet of Things as being a step forward from what we have at the moment, which he described as an Internet of Screens. All of our embedded devices, our laptops, our smartphones, connected together, talking to each other, yielding things like Facebook and other social engines. And this is very much focused on the user and on us as citizens and how we view technology, and by extension, how we view the use of that technology in cities and in our urban environments. This is much more complex, and it is really about creating a version of the Internet of Things that people will use and understand and apply and are designed properly. So what our first speaker was talking about in terms of design is really, really important. A number of those examples are already in our homes. Heating management systems, systems that tell us when we need to purchase dairy goods or fill up the fridge. All of these things are coming into the world at the moment as individual technology solutions. And an increased amount of that will also allow us to develop what's described as the industrial internet, the aspect of the Internet of Things that allows us to deliver efficiencies quickly, a relatively small impact from network systems can yield tens of billions of savings across a variety of different sectors, from oil through healthcare to rail. And these can be captured really from city to city in a very effective way by using the middleware management tools and the technologies that are available. Again, provided they're designed effectively and provided that the municipal planning and the development of the technology and the support of the engagement of the citizen is managed properly. So now we have concepts and we have implementations for network services connected to transportation, safety and security, utilities. A lot of these are coming together as active programs, products that are coming into the market, services from areas that are being rebranded and taken from one domain to another. And it actually generates a series of other problems. We get silos, we get systems like traffic management, water management, parking management, which actually don't talk to each other. The system for smart parking management, the system for energy management, the regional electricity grid, none of these things at the moment talk to each other at all. And in order to change that challenge, we need to address a way of creating managed solutions that maintains the integrity of each individual silo, because they are silos in a way for a reason, but also allows this horizontal of communication to take place so that we can do more and more with the information that's available. In technology terms, that also emerges in the form of massive numbers of different communication standards. The internet has yielded a number of different platforms, and these are growing day by day, and the complexity is also growing with it. So being able to manage the different standards and develop standardization into smart cities is a significant challenge. And this creates a mountain of data. We can talk about the cloud, but actually what we really need to be talking about is a management and delivery of the right type of data to the right people at the right time. And perhaps fundamental in all of this, if we're going to move beyond efficiencies, and talk about a smarter city is finding a way to develop co-creation process, co-development process with the citizen. And for want of a better phrase, that's a bottom-up strategy where we manage to take these technologies and take the fact that a lot of these technologies are now off the shelf and make it easy for people to start to use them and to enable processes that can grow. A lot of what we have at the moment, we've very good examples across lots of cities of programs that struggle from milestone to milestones, a flash of light saying something good can happen, and then that's the end of it. It's back to what Annemie was talking about with fragmentation. It's a huge challenge, and it's really critical when we engage in and around the citizen and try and develop ways of empowering them. So, a quick case study on where the Internet of Things and smarter cities combine. It's a Framework 7 project, European project called Cooperate. And the whole idea of the project was to use Internet of Things services platform that was developed at our institute and develop ways of creating energy positive buildings and neighborhoods, integrating solutions together and working in collaboration with a number of partners across Europe to demonstrate the potential of an approach like this. And what I'm talking about here is one of a number of platforms that are out there. This happens to be the one that we've developed. It's called the 9-Core Internet of Things platform. Okay. And what it's really doing is it's taking separate subsystems that don't talk to each other and creating a middleware so that they can talk to each other, communicate together, can present information to third parties, and can also link to web services. So interoperability is not something that is fixed within this platform. It's something that can be expanded and developed and can be supported by other platforms. It can support knitting. It can link together with the services that I was talking about. It can link to weather forecasting and to the electrical grid. It is being implemented in neighbourhood environments. The initial one is our own campus within the Institute of Technology in Cork, but it's also extending further afield to the local university and into the local housing estates around the campus, project by project, step by step. It's linking in to local data centres. So what we have from a single project is a number of testbed platforms, real-world environments where this implementation is being built and developed and iterated and iterated and iterated. It gives us the ability to measure. It also helps us detect faults and perform the efficiencies and keep the service running that I was talking about. And it is the beginning of a conversation with the citizen in terms of what might be possible and what you can do once you begin to have this layer of information and begin to frame it in a way that they find useful. So to wrap up, Internet of Things could be an answer to the efficiencies. In fact, probably is an answer and is an element in the whole system solution for smart cities. The Internet of Things will happen because of that, because of the skill sets of people and the industries involved. Can it transfer to the development of a new process of interaction with the end user and with the citizen? The answer is yes, and there's a very big but. It requires that we expand the discussion to other disciplines. It requires convergence so that projects that are being developed for smart cities can continue and further developed. It requires a greater understanding of challenges like interoperability between the silos. And it requires us to build things and deploy them and get them out there and work on them again, which is a design ethic, which we really must adopt in this space if we're going to deliver on the potential and get past the hype cycle for the Internet of Things and smart cities. we also need to ensure that there's transparency. And this is where working with local authorities, municipal authorities, third level and industry is really, really important. But the challenge is to take that forward, because it's actually in a way easy for third level organizations, for municipal authorities and industry to work with each other. We've done that for a while. The citizen is still not involved. So perhaps the most important thing, and the most important thing for us to develop this to scale, is engagement. Get out there and talk to people. Thank you very much.
Okay, thanks, Kieran, for such a presentation. It seems that the Internet of Things can be the glue to stick all these key parameters of connections. Okay, let me say last but not least is a presentation of my colleague Hans Martin Neumann. Hans works for the Austrian Institute of Technology in Vienna also. He's a sub-program coordinator of the joint program on smart cities under the European Energy Research Alliance, and he's involved in a series of projects on smart cities at European level and also in Asia. And his research interest is focused on energy and land use. So the floor is yours, Hans.
Okay, Pablo, thank you very much. Good afternoon, ladies and gentlemen. Let me, just start, since I think we are a bit late, with my presentation, which is, I can kick off this way, I think. Here it is, exactly. Yeah, well, it's about, the title is Becoming Smart. I think this is what the whole conference here is about. And I'd like to talk about challenges and opportunities for cities, and a new role, or the new role of researchers play in the smart city debate. The background of this is something you can actually see here on top of the presentation, the logo on the left-hand side. This is the European Energy Research Alliance, or its joint program on smart cities, which I'm representing here. We were invited to host the session here. We were very happy to do that. And I would just like to explain you a bit why we are working on smart cities and how this relates to the bigger discussion on the more renewable energy system and what that means for cities and also for researchers. Why are cities relevant for the energy transition? I think that's quite obvious. If you just imagine of all the people that live in cities, we know that nowadays more than half of the population of the world already is living in cities, and the share is growing. Also cities tend to be industrialized or tend to be centers of energy consumption. There are also computer centers, internet hubs, and so on. So the lion's share of the energy consumption, and thus also the generation of or the emission of greenhouse gases, is of course focused in cities. So that's the bad part of the news, of the message. The good part is of course that cities are also the innovative hubs of the society. This is where the creative people usually work and live. This is where the big companies have their headquarters. This is where the researchers are based. So there's also a lot of potential to overcome or get out of the traditional energy system that heavily relies on for fossil fuels and also nuclear power, and try something new, develop new solutions for a more sustainable, low carbon or even zero carbon energy system. So this is something that is has been broadly discussed for a couple of years already, and this is also reflected on the European level by different programs and targets and goals. I would just like to show one very important document in this context. This is the so-called SET plan, Strategic Energy Technology Plan, which was developed in order to reach the climate and energy goals of the European Commission that have been agreed on by the member states. And this SET plan was at the beginning very much focused on single technologies, but step by step, and there was just a new roadmap developed for this, for the implementation of this plan. The topic of integration, of integrating different technologies, is becoming more and more important. And well, smart cities is, so to say, the overall how to say headline over this kind of energy system integration. So it's the test case where the energy system integration actually takes place is the smart city. So this is how also the energy researchers that are gathering in the European Energy Research Alliance came into the whole discussion. There are many very traditional research organizations represented there, but since the topic is very complex and very interdisciplinary in a way, also the field of the experts involved is becoming wider and wider. Annemie has just showed a slide on that. These are just some of the technological and non-technological aspects that we would associate with smart cities. Of course, there are also others, especially related to ICT, that have been just addressed. But there's a link, of course. Also, if in energy management and in the operation and development of new neighborhoods, of course, the ICT aspects become more and more important. So. I think there are basically 5 challenges if you think about integration and what it means for cities that have to be addressed. Of course, it's how the discussion started in the field of energy research. It's the integration of technologies. Not so many years ago, there was a lot of research and focus on self-sufficient systems that can generate by themselves, so to say, a certain amount of the energy demand. Nowadays, we are more going into interconnected systems, into dynamic systems, into neighborhoods that, or parts of the energy systems and components, and also neighborhoods that talk to each other and that can exchange energy flows. And this has somehow, of course, to be managed. And for this, you need assessment technologies, you need models and tools, but you also need technology for the operation of these complex systems. Second, of course, that also leads to the need to integrate data. We've just heard a lot of it. Some information on it. It's of course the more important the Internet of Things is becoming, and the more important energy demand management and smart networks are becoming. The more important, of course, the topic of data integration is also becoming important. Also, we shouldn't forget that this is all about, if you work in cities, it's all about bringing stakeholders together and bringing also different parts of the administration together. So there's also, you have to talk about process integration, and not necessarily all stakeholders involved have always the same interests, of course. So you need mediation, you need workshops, you need, have to create, if you work on a smart city project, have to create a common ground for discussion and for project development. The integration into the built environment is, of course, also very important. Annemie has addressed this. This is also something that has been, I think, broadly discussed for many years. But since the technology is evolving, also, of course, the challenges for the integration into the built environment are also evolving, and they are not becoming smaller, I would say. And finally, if you generate new knowledge in smart city projects, you also have to find a way, or you have to make sure that others can learn from your pilot project or from your good example. So this is also something that you can call integration. You have to bring together knowledge from different sources, from different cases, and make sure that that the message and the outcomes are spread and well received. So what does that mean for research? That I think in a nutshell it means that the researcher has to get out of his lab. And traditionally, the researcher was someone who observed something going on. Either by analyzing literature or analyzing social processes or analyzing something that was going on in the lab. But it was maybe more the role of an observer. Nowadays, in the field of smart cities, research is working a lot with living labs, with with use cases in real life, where the researcher is not just an observer, but he's also an initiator, he's also a communicator, a mediator, and someone who is working very actively with city administrations, with people from the society, and also, of course, with people from business. And this is something that we broadly discuss in our nice EERA joint program on smart cities. The EERA is the European Energy Research Alliance. It's composed of different so-called joint programs, and this one here is specifically focusing on the topic of smart city development. We have 66 research institutions from 16 European countries involved. Many of them are the, so to say, former or still the traditional national research organizations. We also have new players in the field, and we also have, industrial partners that work with us. One of them is from Spain, Acciona, a very famous company here, of course. This is how we work, or how we are organized. We have inside the joint program 4 sub-programs. One is SP1, dealing with energy in cities, which I have the honor to coordinate. We have another sub-program working on urban energy networks, one on energy efficient interactive building, and one on urban city related supply technologies. I think the most important point here is that it's all about integration. It's not just about single technology, but it's about integrating technology integration, it's about integration into the built environment, also about process integration. Also, we have the wonderful opportunity to work with city representatives. We've just set up in the last year a so-called city advisory board, in which, for example, Mr. Vogl works with us, and other representatives of European cities. And this is, of course, for us as researchers, a good opportunity to exchange ideas. Also, it's sometimes also good to do that outside projects, not just inside projects. There we, of course, always, exchange ideas, but sometimes you just need, a space or a time or a place where you can reflect on something that is maybe, a bit like very innovative, something you wouldn't do within the next 5 to 10 years. But you also need opportunities for this, and this is something that we have now with the City Advisory Board. Regarding the interaction with industrial partners, we are very actively involved in this so-called European Innovation Partnership on Smart Cities and Communities. This is a platform that is organized by the European Commission. Most of the institutions there come from business, I would say, and this is for us a very good opportunity to link with industrial partners, and we are also, of course, hoping to attract more industrial partners as formal members of the European Energy Research Alliance. I think this just gives a brief overview over what we've been doing and what the background of our activities is. These are actually not the goals for 2014. These are the goals for 2015, of course. We will continue our activities, of course. I think for you maybe the most interesting announcement is that we will organize and host an international symposium on smart city indicators and monitoring and KPIs. This is something we have committed. We have submitted as a commitment to the European Innovation Partnership on Smart Cities and Communities. So this is something we will do in close cooperation with the European Commission. We will also try to establish closer links with other research programs that work in similar fields, like the JPI Urban Europe. This is more city research, more on the social science side, I would say. We hopefully will start to develop a smart city roadmap. This is something that we at least internally have been discussing. And of course, we will keep on working in different European networks. Also, an important aspect, and I'd just like to take the opportunity here to spread the message, we are very much interested in working on this use case basis. We are interested in labs, in living labs, in case studies, in something that is taking place in a real environment. If you would like to work with us on this, or if you have even examples or cases to which we can contribute in a way or another, please let us know. We would really be excited to work with you on this. If you need more information, please check our website. We also have just uploaded a very nice promotional video. Doesn't take too long, it's just 3.5 minutes, but very nicely done, I would say. And well, if you have any questions, of course, I'm very happy, and also my colleagues, to answer to your questions. Thank you very much.
Thank you, Hans Martin, for this presentation and for introducing in a comprehensive way the joint program on smart cities, a bit insights on the European Energy Research Alliance. So now it's time to open the floor for questions. So if you have any questions, please. Otherwise, I will ask your definition of smart cities, and we can start a debate on. Please, if you have a question, go to the mics and introduce a bit yourself.
Good afternoon. My name is Nuria Wyckmans. I'm also an architect and researcher, and I teach at the university. We are talking very much today about researchers and policymakers, but we haven't spoken about how do we involve the people who actually put the money in it, which are the developers. Do you have any ideas on how to bring these people forth and become interested in these ideas on site? Thank you.
Yeah, sorry, with all the clapping in the background, I didn't fully hear that. Well, the easiest way is to show how we can make a difference, basically, or from our own experience at least. So basically what we've done is to be present in places where you have developers and building owners and site owners and municipalities, etc., and listen to their challenges, the way in which they work, ask questions whenever a decision is being, so make sure that we are present whenever there is a meeting, whenever a decision is being taken, and then asking, well, do you have to do things like this? What if you would change a little bit of this? The decision you've taken now, how is that going to contribute to reaching smart city goals or emission goals or something similar? And just really not coming with big reports or saying, oh, there's 100 people who have done this or this or this, but just listening to what is it they need and then providing them with that information. Of course, that takes a long time to create that kind of cooperation, but that's basically the best way to do it, I think, because they're not going to read 100 pages, they're not even going to read 30 pages. So the easiest is to actually interact, be present, be active, and make sure, create almost like personal relationships. Between the institution and the developers, but also between people. That's the best advice I can give.
We start now asking developers to bring energy concepts when they are making larger developments for the city. And so the energy topic is coming up, and developers are getting interested in this kind of questions. So it's mainly a rule of the city administration to talk about these things and to say, if we build new buildings here, you must bring an energy concept. That's the way I think.
Yeah, I'd agree with that. I think our engagement with the local authorities tells us that a lot of those needs can be met by framing it properly. But the other key aspect is the personal engagement, because and the willingness to listen as well, because the developers have a series of agendas of their own, which can't be ignored. So we find that what is really an iterative approach, a proper needs analysis, which is holistic. So you can't force feed these energy-based challenges and these solutions down anybody's throat. In order to get them to accommodate and to drive that agenda, I think it's important to build their needs into the overall analysis and frame that. But I think fundamentally it does start with the regional authorities, and they create the discussion, they create the directive.
Any other question? Otherwise, I will recap with 4 or 5 keywords. Integration, engagement, cooperation, and challenges. Still challenge there. So, okay, thank you for your attention. I think a big applause again for the panel for this session. And thank you all for coming.